Okay then, ladies and gentlemen, so we have our motherboard out of our PSX machine and on the bench now. So to give you an idea as to what's what here, this is the top side of the motherboard, and we have the rear mounted controller ports here. We have what they call a D-terminal connection, which is something that's popular in Japan. Essentially, it's an analog video out. It supports high definition. You can use component and things like that. The high definition feeds come out of here. We have a digital optical, and we have an Ethernet. And then over here, this here is I'm assuming, the main processor under the heatsink there. It's a bit of a weird heatsink. Might be worth upgrading that one. But that'll be the Emotion Engine Graphics Synthesizer system on chip there. We have the CXD3098Q. This is what we're interested in. We have the 2 front-mounted memory card slots, memory stick with USB, and these are the front panel buttons here. We have a CR2032 battery just over there, little cell, which they're a 3-volt battery. We'll replace that. That's the original by the looks of it. It's still got the Sony markings on it. And we have the little TDK buzzer there. So that's actually the same parts they're still using in the PS4s. Which, yeah, so there you go. So that's the top side. Bottom side. So that's still the back there, nearest the camera. Obviously everything's now flipped 180 degrees because we're upside down. That's what we've got underneath. Not an awful lot, apart from a few chips there. We have this big space in the middle, which will be quite useful, I think. But yeah, so that's a quick anatomy of it. Over here is where the optical disk drive connections are. We have an LA6058 IC, which is a laser driver, which you find in the later version 9, version 10 PS2. I can't remember what the version of the laser driver is. I think it's a BA something or other in the older machines. So that could be an interesting one. This particular one, I don't know if I'll get this on the camera. It looks a little bit worse for wear. So yeah, hopefully you can see that. So you can sort of see that center pad there. That IC should have a thermal pad on it. Now, it looks like it's long gone from this machine, but you can see there, I don't know if it's oxidized or if it's just got hot. But it doesn't look particularly great, does it? Yeah, do you know what? I'll be minded to actually change that chip if I can find one. Yeah, those chips aren't particularly great anyway. Those are, if you remember back to the version 9, version 10 PS2 days, they used to do something really silly. So if you ever put like a really scratched original disc in there, or you put a poor quality DVD-R in there, then what could happen is it would overdrive current to the laser, which would then blow that IC, and it would also blow the laser. So you'd then have an issue because, of course, your laser would die. You'd replace the laser, but of course, because this driver chip had died, what used to happen is as soon as you powered it on, it would force far too much current through the new diode, and it would blow your new laser as well. So you used to have to change them in pairs. That's what the Comsoft Pick Fix on the version 12s and things were for. It was a different driver chip on those. You could buy a replacement ribbon for these, which I think had some diodes on to try and prevent it from happening, but they weren't particularly great. So you just used to have to be really careful. So what you used to have to do with these is you could actually modify that IC, so that rather than it running from a 12-volt feed, which I think is what they did originally, you could run it from a 5-volt feed. So you used to lift a particular pin. I think it was second in from the bottom, if I remember right. Don't take my word for it, I'll check it. But what we used to do is we used to essentially lift that pin, and then we'd run that to a 5-volt power source, and that used to actually make it much more reliable, which may be an idea for this particular machine. I might do that on this machine because it's the same driver, so I'm assuming it's probably potentially the same issue, which might be why these things go through lasers like they do. Because this driver actually craps out, and you can see on our particular board it's not looking great, so I might see if I can find an old LA6508 kicking around somewhere. It may be an AliExpress job, because I have a feeling if we can still find them in the UK, they're going to be quite expensive, which is the same issue we find with version 12, this PS2 Slim driver chips, which we'll come into on a different day because I've got another video series coming soon, which hopefully you'll all enjoy. And we'll go into the issues with the version 12 Slim PS2. and the laser issues that thing has. But anyway, I digress. But yeah, this chip is not looking great on our machine, so we may well replace that before we start touching the laser. I think it's probably just a good idea, and we may do the 5-volt mod. We'll see. But other than that, also looking around on this board, we have a couple of, these look like some kind of voltage regulator. I haven't googled at all the part numbers on them, but it does have a microchip logo on there, an MM1610. What I'll try and do is, while I'm editing this together, I might just have a quick look around and see if I can find a part sheet for it. If I do, have a look in the description. They look like voltage regulators. It seems they sit on the power rail for the RAM and the Emotion Engine graphic synthesizer. So again, you can see these copper bits on the top. They look like they should have some sort of heat thermal transfer pad on there. Again, long gone. So what we might very well end up doing here is buying some thermal grizzly transfer pads. I can't remember what the name of them are. Conductor is the liquid metal. Thermal pad 8, is it? I think it is. Something like that. I actually put some of those on a PS4 Pro I had once, along with the liquid metal thermal interface material upgrade, and my word, what a difference it made to that machine. So I think for safekeeping, it may very well be an idea to replace our LA6508, put some very high quality thermal transfer pads on that chip, and also these two as well, because we don't need any dramas once this thing is done. And the other thing I think we might have a look into as well is this heatsink. So this looks like it's sitting on top of our Emotion Engine graphic synthesizer chip, but it's only a flimsy, what looks like a piece of aluminium that's held together with that threaded rod that goes through the middle. It's, well, to be honest, if I can get you a shot of it, I will. It's basically just space. It's like that little flimsy metallic structure on the outside edge, but most of it's just hollow. I don't know, it doesn't seem like it does a lot of thermal transfer to me, and these things do run hot, and a lot of them do die from heat, so I think it might be an idea to try and find a better heatsink for one of these things. Now, the annoying thing is I did have one that I took out of an old Skybox a long time ago, and it was actually quite a nice heatsink, and I remember keeping it around because I was thinking that might come in useful one day. And obviously, when we started working on this, I thought, you know what, that'd be perfect for this. That'd be perfect for this chip. But the problem is I've put it somewhere and I've tidied this room out, and I really hope to God it wasn't something, because I had a few components from that box sat over there, and I'm really hoping I haven't just thought, oh, bugger it, I'm never going to use it, I'll just sling it. I really hope I haven't, but I can't find it anywhere, and it's not anywhere I think I would have put it if I'd kept it. So I'm hoping it's just floating around in a drawer somewhere and I'll come across it, but I've had a really quick look around and I can't find it anywhere, so we'll see. But if not, I'm going to have to buy a better heatsink for this thing, I think, and we'll do some upgrades on it, because again, heat is a killer of these machines, and I don't think this is going to be doing an awful lot. So yeah, hopefully you can see there we're a little bit more on its level. So that's the edge. And then, yeah, that's it. So it's basically just space. It's just open space. And really flimsy sort of aluminium. And then it's got this thermal, the bit you can see that's sort of sticking out around the edge here is just a thermal transfer pad, which just isn't good enough, I don't think. It's not going to dissipate enough heat. So it's obviously depending on airflow through the machine to pull air through the fins, I think. But I don't know. I think they've woefully underestimated just how much heat is going to be generated from these machines, and that's not great. So yeah, so we'll have a look at upgrading that as well at some point. Okay, and that's our CR2032, our Sony coin cell battery there. So it's a 3-volt battery. Standard CR2032. These are readily available. I'm sure I've got some spares kicking around somewhere. But as you can see, this is the original Sony cell. So this is probably the original part, which is quite amazing when you think how old this machine is. 2003. Somebody very helpfully on one of the other videos actually left a comment on the video about some of the Japanese writing on the rear label, and it confirms that this machine was built in 2003. So thank you very much to whoever that person is. I'm awfully sorry, I've forgotten off the top of my head what your name is, but I will pop the post up on the screen now so you can have a look and see. And thank you very much for that piece of information. That was absolutely fantastic. But yes, so this battery is 2003. It's 19 years old. Wow. I wonder if it's actually still holding a charge. Should probably have a look. Okay, so that's our battery, and it's been in there that long. You can actually see, look, where the battery terminals are actually, it's weird, it's almost as if the air over time has actually oxidised the surface a little bit, but where it's been under the plastic, it's actually protected it, look. How very cool. Right, so this is supposed to be 3 volts. I wonder what the multimeter says this is generating. So remember, this is a 19-year-old battery. Let's have a look, shall we? So I'm just going to put the multimeter on the battery, and you'll be able to see what that voltage reading is. How well has it fared over the years, do you think? Well, I'll tell you what, for a 19-year-old battery, best part of 2.9 volts. That's probably, it's not bad that, you know. Well, you know, I don't think you can argue with that, really. It's more or less still what it should be. We will replace it, definitely. Its time has come. But yeah, that's interesting, that, isn't it? 19-year-old Sony CR2032 battery. Still more or less 3 volts. Very impressive. Okay, and here's another interesting one for all you PS4 buffs out there. Look at this. Inside our Sony PSX from 2003, we have a Panasonic MN series IC, look. It's an MN673744HLX. I can't find an awful lot online, I can't find a datasheet or anything like that from a really quick look. But anybody knows, who's had their head in a PS4, these things are basically video encoder ICs. And I'm wondering if this one, because of where it's sited, here is just above our D terminal. So I wonder if that's doing our video encoding for our D terminal output potentially. Interesting one. And speaking of interesting, let's have a look at this. An NEC D61052GD with a Dolby symbol on it. Judging by where it is, I think this is where the audio input and output jacks live. So I'm wondering if this is some sort of audio amplifier or Dolby encoder or something like that. Again, I've not found much with the part number and looking for a datasheet or anything, but again, it's interesting all the same. And just as a final one, I noticed this the other day when taking the board out. You can certainly see those 2 caps there towards the rear. Those are definitely swelled up, and those aren't long for this world. Those are 16 volt 1500 microfarad Nishikon caps at 105 degrees. The others are okay. You can see the smaller one down front, so alright. And the big daddy there is absolutely fine. It's just those 2, so we'll get those replaced. They've not done bad for the last 19 years in this environment, but yep, they need doing. And I do have plans for this power supply, so it's not long for this world anyway, but you know, they need doing in the meantime, so we'll swap those out, get them done, and of course this power supply then can be kept as spare, so it's not the end of the world, but yeah, they definitely need doing too. Right, okay then, ladies and gentlemen, so actually I think what I've done here is I've kind of got sidetracked. Whilst it's only a couple of minutes, it's not really relevant to what I actually want to be doing. So I think what I'll do is I'll probably just upload this as a quick short. What the hell, let's put it in and let's see what happens. But yeah, that's a really quick whistle-stop tour of our PSX motherboard. So part 4, in its actual reality, will be us taking a look and finding our mod chip installation points on the PSX motherboard. So stay tuned for that one, coming soon, and I'll see you shortly. Many thanks for watching then, ladies and gentlemen. Hopefully you've enjoyed this video. If you have, then why not check out these recommendations below. Also, please remember to comment, rate, and of course subscribe to the channel if you found this useful. We've plenty more content on there, and there's lots more to come.